Okay, so hello everyone, welcome back to my maths homework. Um, Last time I told you that my homework was kind of missing something, that it was too short. That is so because I separated two questions out of it, which I have tried before, and these involve some advanced concepts. So I didn't want to include that in our general homework because these cannot be done using only inequalities. No, they need to be done using some other kind of other advanced topics such as binomial theorem and minima maxima. So this involves binomial theorem. Let's do it and you will see what I'm talking about. Okay, that's nice. So you got this thing, 1 plus x1 plus into 1 plus x2 into 1 plus x3 all the way till 1 plus xn, and you have defined s as this thing. Okay, so what can we do? First of all, we will apply a regular gm is less than am inequality, which says that the nth root of 1 plus x1 into 1 plus x2 all the way till 1 plus xn, this is the gm of these numbers. This should be less than or equal to their am, so it should be less than or equal to their am, which is you got 1 plus 1 plus 1 all the way till the nth term, which is you got n, right? N times 1 is n, and then you got this thing x1 plus x2 till xn, so that's going to be the sum s, and then this divided by n because it's the am, which can also be written as 1 plus s upon n. Okay, so now let's raise this inequality to the nth power. That will give me 1 plus x1 into 1 plus x2 into 1 plus x3 all the way till 1 plus xn. That has to be less than or equal to 1 plus s by n to the power of n. Okay, now here's the thing, here we can use the binomial theorem. So this thing is basically also equal to 1. uh, Actually I should write n choose 0. Okay, fine. So it's equal to n choose 0 times times 1 to the n times s by n to the 0 power plus n choose 1 times 1 to the n minus 1 times s by n to the first power plus n choose 2 times 1 to the n minus 2 s by n to the second power, and it keeps going like that till you eventually have n choose n of yeah into 1 to the 0th power and s by n to the nth power. Okay, that's nice. Now each of these terms, these can be written in a different format. Just minimize this. Okay, cool. Okay, so these terms, just use some other color. This is basically equal to, okay, you got n choose 0, which is n factorial upon 0 factorial into n factorial. Yes, well that's just 1. Okay, there's no problem with the first one, it's just 1. The second one is s plus s. The next one, uh, for the next one you will be having a 2 factorial in the denominator from this guy, and you will also have n into n minus 1 on the numerator due to this guy, but you got n squared over there, so I'm going to write it like this: n into n minus 1 upon n into n, and then the remaining stuff, which is s squared upon 2 factorial. Similarly for n choose 3, you will have n into n minus 1 into n minus 2 upon n into n into n, and then s squared upon 3 factorial, and it keeps going like that till you have this thing n choose n. So it's going to be there are supposed to be n of them, so you got n into n minus 1 into n minus 2 all the way till 1 upon a lot of n. Okay, a lot of them, n n's. Yes, and then this thing s to the nth power upon n factorial. Yeah, so what can we do from that? We can use the fact that yes, that this thing is obviously equal to 1 and this thing is equal to s. What about this thing? Okay, this quotient, it's going to be less than or equal to if all of these were n. Okay, So it's less than or equal to 1. Similarly, this big quotient is also less than or equal to 1. Right, this thing it's also less than or equal to 1, which means in effect we can say that this sum is actually less than or equal to if we remove these things and write 1 in their place. Right, so just write 1 in their place. That's nice. And that is exactly what we had to prove. We had to prove that this is less than or equal to this thing, which is exactly what we got over here. So just a recap, this thing is less than or equal to this thing, which is basically this thing, which we wrote in a more understandable form, and then we use the fact that every quotient, I mean every coefficient is basically less than or equal to 1 for every term, right? uh, so we use that fact and we wrote this thing, it's less than or equal to this thing. So yeah, that's very correct, which means that this thing is where is that? Yes, which means that this thing is also less than or equal to this thing, this complete stuff. That's nice. That's a nice question. It involves binomial theorem. Okay, the next question involves derivatives and minima maxima kind of concept. Okay, fine. Switch back to red. In how many parts an integer n is greater than or equal to 5 should be dissected so that the product of the parts is maximized? So I still do not get what they mean by dissected. Should it be divided into integers or any kind of real number? We don't know. I mean, any kind of rational number. We do not know that. I think they mean any kind of rational number. It can also be integer, but well, we don't care about it. Okay, so here's the thing. Suppose it is dissected into n integers or n rational numbers or n whatever. Then you have x1 plus x2 plus x3 all the way till x small n. This thing is equal to capital N. Pretty obvious, because yes, this is very obvious. um so let's just divide this thing by small n, which means that capital N upon n, this thing is basically the AM of these numbers. It has to be greater than or equal to their GM, which is the nth root of, well, yeah, x1 times x2 all the way till xn. Yes. So now let's raise this to the nth power. So that will give me capital N upon n raised to the nth power is greater than or equal to x1, x2, x3 all the way till xn. And we have to maximize the product. Okay, fine. So in other words, we also have to maximize this thing so that this product can be maximized. And we know that this happens only when x1, x2, x3 all the way till xn are all equal. Okay, so if all of them are equal, then this is true. Okay, that's nice. Now all we need to do is that we need to maximize this thing, and here's where the derivative parts comes in. So look at it, this is a function in n, which is a function in n equal to capital N upon n raised to the n power. Here we consider that capital N is a constant. Okay, so if we take a derivative of this function with respect to n, that will give me t f of n upon dn. Okay, that is more like taking the derivative of e to the natural log of this thing, which can also be written as n times natural log of capital N upon n. Okay, that is nice. What can we do from that? This is the derivative of e to the n times natural log of capital N minus natural log of small n. Okay, which is, you got this exponential function, it repeats itself. So e to the n times natural log of n minus natural log of small n, but you got to multiply it with the derivative of this thing. So it's going to be into the, now we use the product rule. So the derivative of small n is 1. So you got natural log of capital N minus natural log of small n, multiply to it, and then we keep this and take the derivative of that guy. Well, derivative of this is 0. This is minus 1 by n. Yes. So minus 1 by n into n, that's going to be minus 1. Okay, and we want this derivative to be equal to 0 so that we get the maximum value, right? Obviously this thing cannot be 0 because it's always positive, so cancel that out, which means that this thing, it has to be 0. Okay, that's nice, which means that the natural log of small n minus natural log of natural log of capital N minus natural log of small n is equals to 1. Okay, now that gives me natural log of capital N upon small n equals to 1. Let's raise e to these powers, and it will still be an equality. That will give me capital N upon n is equals to e. That gives me small n equals to capital N upon e. So whatever value of capital N we have to find a value of small n which is very near to this number, capital N upon e. Okay, so that's how we find the maximum value of this thing. Though I do not get it why they gave us this thing, n should greater than or equal to 5. We don't know. Anyway, so that was it. That was the two questions which involved some advanced concept. Okay, see you in the next video.